Today, there are over 8 billion humans living on Earth. We're everywhere. Cities, farms, mountains, deserts. We've built skyscrapers, sent rockets to Mars, created the internet. We dominate this planet like no species ever has. However, if you had looked at the world 900,000 years ago, the picture would have been shockingly different. There were barely 1,280 humans left alive on the entire planet. Not 1.28 million, not 128,000, just 1,280 breeding individuals. That's it. The entire future of humanity is hanging by a thread so thin, it's almost impossible to believe we're here today. If you're using these to fall asleep, that's literally why I make them. So, subscribe maybe, and tell me where you are and what time. I check comments, and it's like Berlin at breakfast, Boston at bedtime, all at once. We fill every corner of the planet, from the busiest megacities to remote villages, from frozen mountain ranges to deserts where life barely clings on. Our species has built skyscrapers taller than ancient mountains of stone, connected every continent with the internet, and even sent machines across the void of space to orbit Mars. We dominate this planet in a way no other species has ever done before. But here is the part that will stop you cold. Roll back the clock to almost 1 million years ago, and everything changes. Forget 8 billion. Forget millions. Forget even hundreds of thousands. At one terrifying moment in deep time, the total number of humans alive on Earth was so small that you could have fit them all into a single sports stadium and still had thousands of empty seats. Just 1,280 breeding individuals. That was it. That was all of humanity reduced to a fragile flicker on the edge of extinction. And the survival of our species hung by a thread so thin that it is hard to believe we are even here at all. If you have ever felt your heart pound after slamming on the brakes and barely avoiding a car crash, then you already know what our ancestors went through. Only this was not a near miss that lasted seconds. This was a crisis that stretched across 117,000 years, a slow-motion catastrophe where 99% of humans vanished from Earth, and only a handful of survivors carried the future of humanity inside their fragile DNA. Imagine walking through a city like Tokyo or New York, filled with millions of people. Now picture almost every single person disappearing until only a tiny scattered group remained. That was reality for our ancestors. The world kept spinning. The sun still rose and set. Ice ages advanced and retreated. Animals roamed the plains. But for humans, it was almost game over. And here is the twist. Nobody knew this even happened until the year 2023. For decades, scientists wondered why human genetic diversity is strangely low compared to other animals. Chimpanzees living in small, scattered groups across Africa show more variation in their DNA than all 8 billion humans combined. Something was wrong with our family tree. There had to have been a disaster that cut us down to almost nothing, but until recently, no one could prove it. Then, new analysis cracked open the story. Hidden in the molecular code of our bodies was the fingerprint of near extinction. Every one of us alive today carries the signature of those 1,280 survivors. Without them, there would be no cities, no art, no science, no music, no future, just silence. The kind of silence that falls when a species disappears forever. But we did not vanish. Somehow, we made it through. And this is the story of how close we came to losing everything, and why the fact that we are still here is nothing short of a miracle. 900,000 years ago, the human story nearly ended. It was not a dramatic asteroid strike or a single giant eruption that almost erased us. It was slower, quieter, the kind of disaster that creeps over generations until you wake up one day and there are hardly any of your kind left. Out of every 10 humans alive on Earth at that time, 9 vanished. Entire groups disappeared, bloodlines gone forever. leaving behind just one tiny thread of survivors. The question that scientists keep coming back to is simple but haunting. How did those people make it when almost everyone else failed? To understand the scale of what happened, imagine your entire city wiped off the map overnight. Not just your city, but every town around it, every village, every extended family. Imagine only a few dozen groups still breathing, scattered across Africa, facing drought, famine, and predators. The total number of breeding humans was so low that you could fit them all into a single high school gym. That is not just rare. That is the kind of number where most species collapse completely. Yet somehow, those few kept going long enough to give rise to you, to me, to everyone alive today. Survival in such a harsh age was never guaranteed. Food was scarce, and the climate was shifting into strange and brutal patterns. Rain stopped falling where it used to, rivers dried up, herds of animals vanished or moved far away. For every human group that failed, there was no second chance. When a few families could not find enough water or food, their children did not grow up. Their genetic lines ended in silence. What makes this moment in history so gripping is that it was not just bad luck. It was a chain of survival decisions made day after day. Where to move, what to eat, who to trust. Every choice mattered in a way we can hardly imagine today. Think about the scale of risk. If a lightning storm burned down the woodland that fed your group, you might not recover. If a disease spread through a camp of 30 people, it could erase half your breeding population in weeks. If conflict broke out between groups, the cost of losing even a few adults could doom your future. Yet some groups learned to adapt. They found refuges with steady water. They changed diets, eating roots, insects, and whatever scraps nature offered. They cooperated more closely, protecting children, sharing knowledge, and keeping fire alive through endless cold nights. These were not just survival hacks. They were the thread that kept humanity from snapping completely. What makes this story feel personal is that every one of us carries the proof of their struggle in our DNA. Each laugh, each idea, each heartbeat is linked to a moment when a small band of people chose to keep moving, to keep fighting, to keep living when extinction was only a breath away. The thread they held onto was so thin it could have broken at any time, but it did not. And because of them, the human story continued. When scientists wanted to understand how close humanity came to vanishing, they did not look in caves or deserts first. They looked inside us. Every cell in your body holds a record of history, not just the story of you or your family, but the entire journey of our species. It turns out that DNA is not just a code for making bodies. It is also a survival ledger, a book written in tiny chemical letters that has been updated with every generation. When researchers opened that book, they noticed something strange. Compared to almost every other animal, humans have very low genetic diversity. This means that two people living on opposite sides of the planet, speaking different languages, and looking different in skin tone or face shape, are still shockingly similar in their DNA. Two chimpanzees from different forests in Africa can be more different from each other than a person from Japan and a person from Brazil. That should not be the case if humans had always been a huge, thriving species. Something in our past cut down our diversity and locked in a smaller range of genes. Population genetics became the detective solving this mystery. By studying the tiny differences that appear in DNA over time, scientists can estimate how many people were alive in the past and when big changes happened. The method works like a molecular clock. Mutations, which are just random changes in DNA, pile up generation after generation. By counting them and comparing patterns across thousands of people, researchers can trace back to when populations grew or shrank. What they found for humans was not normal growth. It was a collapse so deep it left scars in every genome alive today. Think of it like this. If you shuffle a deck of cards millions of times, you expect a wild mix. That is what most species look like genetically. Lots of variation, lots of combinations. But if you suddenly throw away almost the whole deck and keep only a handful of cards, then shuffle those over and over, you end up with much less variety. That is exactly what human DNA looks like. We are a species that once had most of its deck taken away. The first scientists who saw these odd patterns thought maybe their math was wrong. The numbers suggested that nearly all humans disappeared around 900,000 years ago, leaving only about 1,280 breeding individuals. That number sounded unbelievable, almost too extreme to be true, but the signal kept showing up. Different methods, different teams, the same result. Our DNA was carrying the memory of a near-extinction event. Every human alive today is a living archive of that survival story. The genes you carry are not just random. They are the ones that made it through when countless others were lost forever. That is why population genetics matters. It reveals the hidden clue that proves we came terrifyingly close to never existing at all. And it shows us that the past lives inside us, written in every cell, waiting to be read. When the first signals of a human population crash appeared in the data, even the scientists did not want to believe it. The numbers were too extreme, almost like a bad joke. In the year 2018, researchers began running massive genetic models on thousands of human genomes from around the world. They were not expecting anything earth-shattering. It was meant to be another careful study of population history, a way to track migration patterns and mutation rates. But then the models collapsed. Suddenly, the calculations showed humanity falling off a cliff around 900,000 years ago. Not a gentle decline, not a dip, but a plunge so deep that it suggested almost everyone alive at the time was gone. The first reaction was disbelief. Maybe the computer program had glitched. Maybe there was a mistake in the code. The numbers said the global human population shrank by more than 98% and stayed critically low for over 100,000 years. That is not a normal blip. That is an extinction-level event. The researchers checked again. Same result. They rewrote the equations. Same result. They even tested with different methods that did not rely on the same assumptions. No matter what angle they looked from, the picture was the same. Humanity had been reduced to about 1,280 breeding individuals, a number smaller than many high schools today. For years, the idea floated in the background of genetic research. Everyone knew humans had suspiciously low diversity, but no one dared to imagine the bottleneck was this severe. It was easier to assume the signal was noise, or that it came from a smaller migration event like the one 60,000 years ago when humans left Africa. But the data kept pointing further back to a time almost no one had seriously studied. Finally, in 2023, the results were published in the journal Science. The bottleneck was real. Humanity had come terrifyingly close to disappearing forever. Think about the courage it takes to publish something like that. You are basically telling the world that the story of human survival is far more fragile than anyone thought. The research team triple-checked every number before they dared go public. They used a new computational method called FitCoal, short for Fast Infinitesimal Time Coalescent, which allowed them to track population changes across hundreds of thousands of years with incredible precision. And what it revealed was not just a dip in numbers, but a desert. For more than 100,000 years, humanity lived balanced on the edge of extinction. The bottleneck nobody saw coming was not just a scientific curiosity, it rewrote our understanding of human history. It told us that survival was never guaranteed, that our ancestors faced odds so bad most species would not have recovered. Yet here we are, 8 billion people, living proof that sometimes the impossible really does happen. If you want to understand how scientists can look back hundreds of thousands of years without a time machine, you have to start with mutations. A mutation is simply a small change in DNA. Maybe one letter out of billions switches to another, maybe a chunk gets duplicated, or maybe something tiny is deleted. Most of the time, these changes do not do much. They slip quietly into the code and get passed on from parent to child without anyone noticing. But over long stretches of time, those little changes add up. And that is where the idea of the molecular clock comes in. Think of DNA like a giant book that has been copied by hand for millions of years. Every time a new copy is made, a few typos sneak in. If you compare the copy today to an older one, you can count how many typos are different. The more changes there are, the longer the time since the copies split apart. That is exactly how scientists use mutations. By comparing DNA between people today, they can work backwards and estimate when groups of humans shared common ancestors. The mutation rate becomes like the ticking of a clock, each small change a tick marking the passage of time. The key is that mutations happen at a fairly steady rate. It is not perfect, but on average, scientists know how often a change occurs in human DNA over each generation. That means if they take DNA from thousands of people around the world and measure the differences, they can turn those differences into dates. It is like finding a calendar written into your cells. By using this molecular calendar, researchers discovered the sharp drop in human population around 900,000 years ago. They could see the sudden thinning of the genetic tree, like a forest that has been cut down to just a few lonely saplings. What makes this idea powerful is that it does not rely on fossils or artifacts that might never be found. Fossils can be rare, ancient tools can be destroyed, but DNA is everywhere, in every living person. It is the ultimate archive, carried silently inside us. That is why scientists trust the molecular clock to answer questions about times and places where the fossil record is almost empty. Of course, it took decades to make this method precise. Early attempts were like trying to read a book through a keyhole. Scientists could tell something happened, but not when or how. With better technology and bigger samples of DNA, the picture sharpened. By the time Wang Zhu and his colleagues ran their analyses in the late 2010s, the clock was accurate enough to show not just one bottleneck, but the exact severity of it. That is how we know humanity fell to about 1,280 breeding individuals and stayed low for 117,000 years. The molecular clock is a reminder that time is written into us. Every heartbeat, every breath, every thought is powered by DNA that carries the marks of the past. The reason we can tell this story at all is because our bodies never stopped keeping track tick by tick, generation after generation. The stage for humanity's near extinction was set not by a single disaster, but by the planet itself changing the rules. For millions of years, Earth's climate had followed a rhythm. Ice ages would come and go in cycles of about 41,000 years. Ice sheets grew across the north, then melted back, seas rose and fell, but life adapted. It was harsh, yes, but predictable. Then, around 900,000 years ago, that rhythm broke. The cycles stretched out to 100,000 years, and the ice ages became brutal beyond anything our ancestors had known. These new glacial periods were longer, colder, and harsher. Ice sheets expanded across North America, Europe, and Asia, locking up so much water that sea levels fell by hundreds of feet. Land bridges appeared between continents, joining what had once been separated. Ocean currents shifted, temperatures plunged, and Africa, the cradle of our species, suffered most of all. As the world froze in the north, rainfall patterns in Africa collapsed. The monsoons that once fed rivers and grasslands weakened or stopped completely. Lush forests and woodlands withered into scrubland and then into desert. Imagine being an early human in this world. The places your parents and grandparents had hunted were gone. Rivers that once flowed all year became dry, cracked beds. Herds of animals moved away or died out. Plants that fed your people disappeared season by season. This was not just a drought that ended after a few bad years. This was a permanent transformation that stretched on for tens of thousands of years at a time. Survival meant not just enduring one bad season, but generation after generation of scarcity. This shift is known as the mid-Pleistocene transition, and it reshaped every living thing on Earth. Species that had thrived for millions of years suddenly faced impossible odds. In Africa, many large mammals went extinct. Whole ecosystems collapsed, and humans, who were already vulnerable because of their small numbers and scattered groups, were pushed to the very edge. Our ancestors were not masters of the planet then. They were one more struggling animal trying to make it through in a world turning hostile. What makes this moment so important is that it explains why the human population crashed so dramatically. Climate broke the rules. The environment no longer gave our ancestors enough resources to survive in large numbers. Groups died out, one after another, until only a tiny remnant remained. Those survivors were forced into refuges, pockets of land where water still trickled and food could still be found. Everywhere else became too dry, too barren, or too unpredictable. When you look at the genetic evidence today, that population bottleneck lines up almost perfectly with the mid-Pleistocene transition. It is as if the planet itself was testing humanity, stripping away every advantage, leaving only those who could adapt quickly enough. The survivors were not just lucky. They endured the harshest climate experiment in human history, and the traits they carried through those 100,000-year ice cycles would shape who we became forever. Survival is never about one single problem. It is about what happens when problems stack together faster than you can handle them. For our ancestors 900,000 years ago, that stack became a perfect storm. Climate cycles had stretched out into brutal 100,000-year freezes. Africa was drying, and the ecosystems that had sustained human life for millions of years were collapsing. But drought alone did not doom us. It was drought combined with everything else breaking down at the same time. When water disappeared, plant life withered. Without plants, grazing animals starved. Without those animals, the predators that hunted them died out. Whole food webs crumbled piece by piece. Imagine walking through a land that had once been alive with antelopes, elephants, and rhinoceroses, only to find silence. A world where each season was worse than the last. The animals you depended on for food were gone. The plants that your group had gathered for generations were gone. Even the rivers that guided migration routes had become dust. And just when survival could not get harder, random disasters struck. A wildfire sweeping through a refuge that had barely sustained a few families. A volcanic eruption spreading ash across already dry plains. A disease moving through a tiny group of 30 or 40 people, wiping out half of them in weeks. In large populations, disasters can be absorbed. In populations already pushed to the edge, they can be final. Every group of humans was living one bad season away from erasure, and many did vanish. This is why the human bottleneck lasted so long. It was not just a single sharp event. It was the grinding weight of countless smaller crises piling up. Year after year, decade after decade, generation after generation, humanity lived in survival mode. For 117,000 years, the species walked a knife edge. Most lineages fell. Only a scattered few endured. Think about how thin the margin was. If even one more random disaster had struck the wrong group at the wrong time, there might not be any humans alive today. The fact that the thread held is almost unbelievable. A few bands of survivors, maybe living near hidden springs or in valleys that held just enough food, managed to keep going when the rest of the world seemed determined to erase them. The genetic evidence makes it clear. 98.7% of our ancestors disappeared. We are the children of the remaining 1.3%. The odds against that survival are staggering, but that is the reality of evolution. Sometimes the difference between extinction and endurance is not strength or intelligence. It is luck combined with just enough adaptability to push through when everything else fails. The perfect storm for disappearance did not destroy us completely, but it came closer than almost any other species has ever endured. and the scars of that storm still live inside our DNA. Picture a world where almost every sign of humanity has vanished. Vast stretches of Africa have become dry and empty. Forests that once sheltered hunters are now barren scrub. Rivers that once ran steady are nothing but cracked scars across the land. Most human groups are gone, erased without leaving a trace. But here and there, in hidden corners, tiny bands of survivors remain. They gather around small springs that never dry, or huddle near river cuts where a trickle of water still flows, or cling to rift valleys that create their own pockets of rain. These refuges became the last sparks of human survival. Imagine one of those groups, 30 or 40 individuals, everyone related in some way, everyone counting on each other. At night, they sit around a small fire, the flames casting faint light against the dark. That fire is more than heat or cooking fuel. It is life itself. It keeps predators away, lets children sleep safely, and gives the group an extra hour to plan or tell stories. When the winds blow cold from the glaciers to the north, the fire is the difference between life and death. Food is whatever they can find. With the big herds gone, they turn to roots and tubers hidden underground. They dig with sticks, scrape bark for nourishment, and gather insects in huge numbers. Termites, beetle larvae, and crickets may not sound like survival food today, but back then they were steady calories. Occasionally, the group is lucky enough to bring down a small animal, maybe an antelope or warthog. Every part is eaten, roasted over the same fire that warms their hands. Nothing is wasted. Water is the hardest. Whole regions are bone dry, so knowledge of where to dig shallow wells or which seasonal streams last the longest is precious. Elders who remember hidden springs are treated with the highest respect because their memory is survival. One forgotten path could mean the group does not live to see the next season. Even more fragile than food or water is the social bond. With numbers so low, the loss of a few adults to accident or illness could doom the entire lineage. That is why cooperation was not optional. It was everything. Families cared for the sick, shared food with the weak, and taught children relentlessly. Every scrap of knowledge, every trick for finding roots or making fire, had to be passed on before it could be lost. Oral teaching became as essential as food. Without it, survival skills would vanish with each death. These scattered bands did not know they were carrying the fate of the species. To them, life was only about the next day, the next drink of water, the next meal. Yet in keeping those small fires burning, they preserved humanity itself. Against all odds, those tiny clusters of survivors became the ancestors of us all. They were the last, small fires in a dark world, embers that refused to die out until the world became livable again. The sun rises over a landscape that looks more like bone than earth. Cracked mud stretches in every direction, broken only by sparse shrubs clinging to life. For a small band of humans 900,000 years ago, this is another day in the dry. There is no luxury of sleeping in. At dawn, the air is cool enough to move, and the group must act quickly before the heat becomes unbearable. Survival follows a strict order: water first, food second, danger always. The hunt for water begins before anyone eats. A few of the adults lead the way, scanning the horizon for signs that most of us today would miss. The flight of birds circling low, a patch of greener plants, the shimmer of damp soil under cracked clay. They remember where a seasonal stream sometimes lingers and hope it has not disappeared this year. Children follow silently, their bare feet padding over the dust, every step a reminder that they cannot afford to waste energy. By mid-morning, the group finds a shallow hollow where the soil is darker. They dig with sticks and hands until brown water seeps up. It is not much, but it is enough to wet lips, fill small gourds, and keep them moving. With water secured for now, the focus turns to food. The forests that once fed their ancestors are gone, replaced by scrubland and scattered grass. Hunting large animals is rare. so they search the ground for tubers, digging deep for starchy roots that can be roasted later. Children look for insect mounds, prying open termite nests for crunchy protein. A few of the men track faint hoof prints, hoping to find a weakened antelope left behind by a herd. If luck is on their side, they might return with meat. If not, the day's calories will come mostly from bugs and roots. But danger never leaves. Every decision carries risk. When they kneel to dig for roots, they must watch for snakes curled in the dust. When they follow tracks, they risk crossing paths with lions desperate for food just like they are. Even the waterhole is not safe. Crocodiles sometimes linger in the muddy pools, waiting for anything that dares to drink. The adults move carefully, every sense alert, knowing that one mistake could mean the loss of a parent, a hunter, or a child. As the sun drops and the land cools, the band returns to their shelter. It may be a shallow cave, it may be a cluster of rocks where a fire can be built. The small flames crackle, smoke rising into the star-filled night. The group eats what little they found. Tubers roasted soft, insects crisped in the fire, maybe a strip of meat if the hunt succeeded. Children curl against parents, the fire keeping predators at bay. This was daily life in the bottleneck. Not progress, not building, just survival. Every sunrise was another chance, every sunset a victory. Day after day, year after year, the math stayed the same. Water first, food second, danger always. And somehow that was enough to keep the human story alive. Fire was more than light in the darkness. It was survival, transformation, and the beginning of something new. For our ancestors trapped in the bottleneck 900,000 years ago, fire meant the difference between scraping by and building the foundation of what would eventually become human culture. Without fire, every day was a brutal struggle. With it, life expanded just enough to give our species a chance. The first gift of fire was food. Before humans learned to cook, much of what they ate was tough, fibrous, or even toxic. Roots were hard to chew and provided few calories raw. Meat carried parasites and spoiled quickly. But once groups figured out how to control fire, everything changed. Roasted meat became safer, killing invisible threats that could wipe out a small band overnight. Cooking plants broke down stubborn fibers and unlocked more energy. Even insects, once eaten raw, became more palatable when crisped in flames. Fire multiplied the calories from every bite, which meant children grew stronger, adults lasted longer, and groups had a better chance to survive lean seasons. But fire did more than feed bodies. It gave time. Without fire, darkness fell hard and fast. Predators prowled at night, and humans had little. When a species shrinks to almost nothing, survival is not about strength alone. It becomes about the thousands of small choices made every day. For our ancestors living through the bottleneck, cooperation was not a luxury or a moral lesson. It was the only way to stay alive. A group of 30 or 40 people could not afford constant fighting or selfishness. Every adult mattered. Every child mattered. Losing one meant losing knowledge, skills, protection, and the fragile balance that kept the group going. Imagine a band of humans camped near a dwindling stream. Food is scarce, water unpredictable, predators close. If one person hoards food, others go hungry. If a fight breaks out and one hunter is injured, the whole group weakens. If someone with vital knowledge dies without teaching the next generation, that knowledge is gone forever. The only solution was to learn cooperation so deeply it became instinct. Our ancestors smoothed over conflicts quickly because anger wasted energy they could not spare. They shared food even when stomachs ached. They cared for the weak because one more pair of hands, even small ones, increased the chances of survival tomorrow. Knowledge was perhaps the most precious resource of all. An elder who knew which roots were edible or which paths led to water carried information worth more than a storehouse of food. That is why teaching became essential. Children were not just raised, they were trained constantly, absorbing every skill that could help them survive. Storytelling around fires was not entertainment. It was education disguised as memory. Each tale preserved survival strategies tested over countless seasons of hardship. Cooperation also extended to protection. At night, adults took turns guarding the fire, making sure it did not die. If it went out, the group could not just strike a match and relight it. Fire meant warmth, safety, and cooked food. Protecting it was protecting life itself. Mothers nursed not just their own children, but sometimes the children of others, because every infant lost was a piece of the future lost. Hunters worked together to chase down small game, sharing the reward because tomorrow the luck might belong to someone else. It is tempting to imagine early humans as fierce and brutal, each one only for themselves. But the truth is the opposite. The people who survived were the ones who learned to cooperate better than any other animal alive. They shared when it hurt. They forgave when it was hard. They thought about the group as much as themselves. And over generations, those traits became hardwired into human behavior. The 1,000 decisions that saved us were not dramatic. They were small, repeated endlessly. A shared meal, a conflict avoided, a child taught, a fire protected. Those choices added up to survival. Without them, the bottleneck would have snapped, and humanity would be a forgotten branch on the tree of life. Instead, here we are, the descendants of people who chose cooperation again and again until it became who we are. When humanity was reduced to only about 1,280 breeding individuals, evolution began to work differently. In a large population, new traits spread slowly. A useful change might take thousands of years to become common, and harmful quirks often get diluted away. But in a small group, every shift in DNA has a magnified effect. It is like putting life into a pressure cooker. The heat is higher, the change is faster, and the results impossible to ignore. Imagine one child born with a small genetic advantage. Maybe they could digest a new type of food more efficiently, or maybe their brain circuits made them slightly better at problem solving. In a group of millions, that edge would hardly matter. But in a group of hundreds, where survival was desperate and every mouth counted, that advantage could spread through the whole population in just a few generations. Soon, most of the survivors would carry it, not because evolution was gentle and slow, but because survival demanded speed. The same was true for harmful traits. In a big population, dangerous mutations often disappear when unlucky individuals fail to pass them on. But in a tiny gene pool, harmful quirks can get stuck. Inbreeding makes them harder to escape. Some of the weaknesses we see in humans today, like our higher vulnerability to certain diseases, may trace back to those long years when bad genes had nowhere to hide. The bottleneck was both a curse and a gift. It stripped away much of our diversity, but also forced rapid change that shaped who we are now. Brains may have been the most important part shaped in this crucible. Groups needed cleverness more than strength. They had to find new foods, invent new ways to hunt, and cooperate better than ever. A small boost in memory or communication could mean the difference between life and death. Those who carried sharper minds passed them on, generation after generation, until intelligence itself became one of humanity's greatest survival tools. Bodies also adapted. In harsh, dry environments, stamina mattered. People who could travel farther for food and water had better chances of keeping their families alive. Over thousands of years, endurance running, efficient cooling through sweat, and a lighter build for long journeys may have become more common. Even behaviors were reshaped. The instinct to share, to teach, and to trust close relatives was not just culture. It was evolution selecting for cooperation. Groups that fought too much vanished. Groups that worked together lasted. The pressure cooker of a small population left scars that we still carry. Our low genetic diversity is a reminder of how close we came to disappearing. Our vulnerabilities are reminders of traits that clung on even when they should have been lost. But our intelligence, our adaptability, and our capacity for teamwork are proof of the advantages that spread fast under that extreme pressure. For 117,000 years, humanity lived in this crucible, and the species that stepped out was no longer ordinary. It was something new, something built to endure. Every human alive today carries a scar deep inside their DNA, a permanent mark left behind during the darkest chapter of our species' history. It is found in chromosome 2, one of the 46 chromosomes that make up the human genome. What makes it special is that it was not always there. Our closest relatives, chimpanzees and gorillas, have 48 chromosomes. Somewhere around 900,000 years ago, during the long bottleneck that almost erased us, two ancestral chromosomes fused together into one. That fusion left a visible seam in our DNA, a scar that scientists can still point to today. Chromosome fusions are incredibly rare. They usually happen when two chromosomes accidentally join end to end during cell division. Most of the time, they cause serious problems and never spread beyond a single individual. But in the tiny, fragile human population of that era, the rules were different. With only about 1,280 breeding individuals alive, even rare mutations could spread quickly. If a single survivor carried this fused chromosome and passed it on to children, it would not take long before the entire group shared it. Generation after generation, the fusion became universal until every human carried it. Scientists can see the exact site where it happened. On chromosome 2, there are molecular scars that show where two ancient chromosomes once joined. It is like looking at a healed fracture in a bone. The evidence is unmistakable. What is even more astonishing is how much this fusion may have changed the course of our evolution. Near the fusion site are genes that influence brain development and neural function. Some researchers believe that this event may have helped push human intelligence further, giving us an edge in problem solving and adaptability right when we needed it most. Think about the timing. The fusion happened while humanity was nearly extinct, clinging to survival through 117,000 years of brutal climate shifts. If our population had been larger, the mutation might have been lost in the shuffle. Instead, the bottleneck created the perfect environment for it to spread. A small change in a small group multiplied until it defined the future of an entire species. Today, every one of the more than 8 billion humans carries chromosome 2. It is part of what makes us different from our closest relatives. But more than that, it is a reminder of how close we came to disappearing and how strange twists of fate shaped who we are. Without that fusion, our brains and behavior might have developed differently. Maybe we would never have painted caves, built cities, or sent rockets into space. The scar in chromosome 2 is not just a quirk of genetics. It is a time capsule from the bottleneck, a record of survival written in our cells. When you think about it, the fact that all of humanity shares this fused chromosome means we are all connected by the same ancient accident, the same fragile thread of survival that almost broke. When scientists look back at the fossil record of humans, they expect to see bones scattered across time like dots on a map. But between 950,000 years ago and about 650,000 years ago, something strange happens. The dots vanish. Fossils that should mark the presence of early humans almost completely disappear. For decades, this puzzled researchers. Where were the bones, the tools, the traces of life that should have been there? They called it the fossil gap, a stretch of time where humanity seemed to vanish from the earth. At first it looked like a mystery, but now we know it was a signal, a silent witness to just how close we came to extinction. Fossils are rare even in the best of times. For bones to survive hundreds of thousands of years, the conditions have to be perfect. The body has to be buried quickly, protected from scavengers and weather, and preserved in sediments that later harden into rock. Out of all the humans who have ever lived, only a tiny fraction left fossils behind. Now imagine a world where there are only a few hundred or 1,000 breeding individuals scattered across an entire continent. The odds of any one of them dying in just the right place to leave a fossil are almost zero. That is exactly what happened during the bottleneck. The silence in the ground is evidence of how small our population really was. It is not that humans vanished completely. It is that there were so few of us, spread so thinly across Africa, that the chances of leaving behind bones for future scientists to find became microscopic. The emptiness of the fossil record matches perfectly with the genetic evidence showing that humanity was reduced to about 1,280 survivors. The fossil gap is not a coincidence. It is the geological echo of our near extinction. When researchers first noticed this absence, they did not know what to make of it. Some thought maybe fossils had yet to be discovered, that we just had not dug in the right places. Others suspected that human populations had shifted to areas where preservation was unlikely. But as time passed and the gap remained, it became harder to ignore. Now, with the confirmation from DNA analysis, the fossil gap makes sense. It is not a hole in the data. It is the data. It is proof that there were simply too few humans to leave behind much of a trace. What makes this even more sobering is the contrast with periods before and after. Before the bottleneck, fossils appear more regularly. After the climate eased and populations grew again, the dots on the map return. But during those dark 100,000 years, the Earth holds almost nothing. The fossil gap is a reminder that sometimes the absence of evidence is evidence in itself. It tells us that our ancestors walked the Earth in numbers so small that their bones, like their voices, almost disappeared forever. When the human population finally began to recover after the bottleneck, something remarkable happened. Out of that tiny pool of survivors, different branches of humanity began to grow in separate directions. The ancestors of modern humans, Neanderthals, and Denisovans all came from the same fragile root, yet each faced different environments and pressures that shaped them into distinct species. It was like a tree forced through the narrowest gap in the rock, then splitting into 3 sturdy branches once it had room to grow again. In Africa, the group that would eventually become modern humans stayed behind. They faced a landscape that was unpredictable, with climates that swung back and forth between wet and dry. This constant instability pushed them to become adaptable. They had to use many different food sources, invent flexible tools, and rely on cooperation to get through shifting conditions. It was this adaptability that would one day allow their descendants to spread across the globe. Meanwhile, some groups moved north into Europe. They encountered a colder, harsher world where survival demanded strength and resilience. These people became the Neanderthals. Their bodies grew shorter and more muscular, built to endure freezing winters and long hunts in icy forests. Their skulls developed heavy brows and large noses, adaptations that helped warm, cold air. They were brilliant hunters, able to take down massive Ice Age animals, and they built cultures shaped by the demands of survival in Europe's extremes. Another group travelled east into Asia. These became the Denisovans, a mysterious branch we know mostly from DNA and a few fossil fragments. They were as successful as Neanderthals, but in different ways. Denisovans spread across vast territories, from Siberia to Southeast Asia, adapting to high altitudes in the Himalayas, and perhaps even mastering early seafaring to reach distant islands. Their genetic legacy still lives on in modern people in parts of Asia and Oceania. What is astonishing is how closely related all 3 branches remained. Even though they adapted to very different worlds, they were not so different that they could not interbreed. Genetic evidence shows that modern humans mixed with both Neanderthals and Denisovans multiple times. These meetings left behind fragments of DNA that still exist in us today, like faint echoes of cousins we once knew. The split into 3 lineages shows the power of evolution under pressure. From the same bottlenecked population came three solutions to survival. One became flexible and inventive. One became strong and specialized. One became explorers of Asia's extremes. All were successful in their own way. For hundreds of thousands of years, three kinds of humans walked the earth at the same time, sharing a fragile family bond shaped by the same near-extinction event. The story of branches under pressure reminds us that humanity was never a straight line. We are not the only version of what it means to be human. We are simply the branch that lasted longest, carrying the shared memory of a family that was tested, divided, and forever changed by survival. Long before writing, long before schools, the most important lessons humans learned were carved in stone. Tools were not just objects, they were survival itself. Around the time of the bottleneck, and in the long recovery that followed, humans began to develop stone hand axes and cutting edges with remarkable consistency. These were not random flakes chipped from a rock. They were carefully shaped and standardized. That shift was huge because it meant something new was happening. Knowledge was being shared across groups faster than genes could spread. Skills were becoming culture. Imagine a child watching an elder carefully strike stone against stone, chipping away flakes to reveal a sharp edge. It looks simple, but it is not. The angle, the force, the choice of rock, all of it had to be learned. You could not just guess and get it right. It took years of practice and instruction. This was apprenticeship, the beginning of teaching as technology. A child who mastered the skill could feed a family. A child who failed might doom them. That pressure meant teaching became just as important as making. What is incredible is that we can see this in the archaeological record. Hand axes, found thousands of miles apart, often look almost identical, as if the same teacher had instructed people across continents. But the truth is even more impressive. Groups were passing down standardized methods, preserving knowledge generation after generation, keeping techniques alive longer than any single person could. That kind of cultural memory gave humans a survival edge no other animal had. Tools also became a form of communication. A finely made blade was not just useful, it told others that the maker knew their craft. It may have even been a way of attracting mates or building alliances. If you could make good tools, you proved you were worth keeping alive, worth partnering with, worth trusting. In a world of scarcity, skill meant status. The leap from tools to teachings also changed how humans thought. When knowledge had to be taught step by step, humans developed better memory, better focus, and better ways of explaining ideas. Teaching itself shaped our brains. You could say that every stone flake carved away was also carving pathways in the human mind, sharpening not just tools but intelligence. This was the start of something bigger than survival. It was culture taking root. Once humans learned how to preserve and spread knowledge outside of DNA, the pace of progress accelerated. Instead of waiting for evolution to hardwire an ability, a child could simply be taught. That was faster, more flexible, and it meant humans could adapt quicker than the climate could destroy them. Tools became teachings, and teachings became tradition. The survival tech of our ancestors was not only stone or fire. It was the ability to share knowledge across time, to make sure every child carried the skills of their ancestors. That was the moment humanity became more than just another animal. It was the beginning of us becoming who we are. If you looked at a map of the world 900,000 years ago, you would not see cities or borders or highways. But if you could see the hidden connections between human groups, you would notice something just as important. Invisible roads stretched across Africa, linking scattered bands of survivors together into a fragile web. These paths were not carved into the land. They were made of memory, kinship, and necessity. They carried the lifeblood of a species on the edge of extinction, moving not only materials but also knowledge and people. A small group living near a spring might discover a new way to sharpen stone or a new plant that could be roasted for food. That discovery was not just kept secret. It spread when members of the group met others, trading not only objects but information. Sometimes these exchanges happened by chance when two groups crossed paths at a watering hole. Other times, they were intentional, built around marriage alliances. A daughter might leave her family to join another band, carrying with her stories, skills, and genetic diversity that could prevent inbreeding. These exchanges stitched the scattered remnants of humanity into what scientists call a meta-population, a network of groups that rose and fell but survived as a whole. Evidence of these invisible roads can still be seen in stone tools. Archaeologists have found identical designs appearing thousands of miles apart during the bottleneck years. The only explanation is that knowledge travelled faster than the people themselves. That is, culture acting like a survival highway. Even if one band perished, the skills they had shared might live on in another, keeping the thread of humanity alive. Materials also travelled along these hidden routes. Obsidian blades found far from volcanic sources show that early humans were moving rock across long distances, passing it from hand to hand. Each exchange was more than trade, it was trust. Sharing precious materials built bonds that could mean the difference between life and death during a bad season. It also proved that groups did not see themselves as entirely separate. They were part of a larger web, fragile but strong enough to last over generations. What makes these invisible roads so fascinating is that they existed long before maps or writing. They were held in stories and memory, taught to children as part of survival training. This spring leads to that valley. This family connects to that clan. This tool came from that mountain, far away. Every piece of knowledge was part of the web. Without these connections, the bottleneck might have broken us completely. Isolated groups would have run out of resources or collapsed from inbreeding, but the web kept them alive. The invisible roads carried food, mates, tools, and stories, turning scattered bands into a species with a shared fate. When you look at the modern world of highways, shipping lanes, and internet cables, you are seeing the descendants of those first hidden roads. They were humanity's first network, the reason the small sparks of survival never went out. At some point during the long bottleneck, survival demanded more than sharp stones and small fires. It demanded sharper minds and better ways to connect those minds together. That is where language came in. Not just sounds or calls like other animals, but true complex speech. Words became the ultimate survival tool, a multiplier that let humans plan, teach, and negotiate. When language found its voice, small scattered groups transformed into something bigger, something like superorganisms, where the intelligence of one person could be shared by all. Imagine a group trying to hunt. Without language, coordination is limited to gestures and cries. With language, hunters can plan before the chase even begins. They can say who will circle left, who will drive the animals, who will wait in ambush. They can warn of dangers that are not visible, like a lion seen near the river the day before. That kind of coordination changes the odds completely. A group that can talk out hunts does not just survive better, they thrive compared to groups without it. Teaching also became infinitely more powerful with speech. Before, skills had to be copied by watching. Now, knowledge could be explained step by step. A parent could tell a child which plants were poisonous and which roots could be roasted. They could pass on warnings, describe landmarks, or recount how an ancestor survived a drought. Every story was a package of survival information, compressed into words and carried forward to the next generation. Language turned memory into a community resource, instead of something locked inside one person's head. Negotiation was another gift of speech. When resources were scarce, fights could easily break out between groups, but words offered a new path. Instead of violence, people could talk. They could bargain, trade, arrange marriages, or share water sources. Speech reduced conflict at a time when the loss of even a few adults could be catastrophic. Words kept peace where fists or stones would have destroyed fragile communities. The power of language was not just practical, it changed how humans thought. With words, people could share ideas about things not in front of them. They could talk about the past and imagine the future. They could create shared myths and traditions that bound groups together across generations. Language built trust, identity, and belonging. In a population so small, these bonds were everything. Over thousands of years, the ability to speak complexly would refine our brains even further. Evolution favored individuals who could learn and use language well, because they were more likely to survive and pass on their genes. Slowly, the species became not just a collection of individuals, but a networked intelligence. The survival of the group was amplified by the voice of each member. When language found its voice, humanity became unstoppable. It turned survival from a lonely fight into a shared effort. It made small fires into cultures, scattered bands into societies, and fragile survivors into the ancestors of every person alive today. For 117,000 years, the world pressed down on humanity with relentless drought and brutal cold. Then, slowly, almost imperceptibly, the pressure began to ease. The rains returned, not in a sudden flood, but in cautious rhythms, drop by drop, season by season. Rivers that had long been dry began to flow again. Grasslands crept back into places where only dust had reigned. Herds of animals that had vanished from whole regions started to reappear. It was not a miracle moment, but a long unwinding of disaster, and it opened the narrow channel through which our species had been forced to squeeze. For the survivors scattered in small bands, these changes must have felt like the world breathing again. Where once waterholes had been guarded like treasure, now more springs began to appear. Where food once meant scraping at roots and raiding termite mounds, now plants grew taller and animals gathered in larger numbers. Populations that had been stuck at the edge of extinction for millennia began to grow. Children were more likely to reach adulthood. Families expanded beyond a handful of individuals. Slowly, the fragile spark of humanity began to brighten. As groups grew, they spread. A valley that had once supported only one band could now support two. When resources overflowed, humans wandered further, following rivers that led into new lands, chasing herds into unfamiliar territories. These movements stretched invisible roads into new directions, carrying with them tools, fire, language, and the memory of survival. What had once been a single small thread of people began to branch. This branching marked the start of one of the most important shifts in human history. The survivors no longer faced exactly the same conditions everywhere. Some remained in Africa's changing landscapes, where adaptability continued to be the key to survival. Others pushed into Europe, where colder climates shaped them into the stocky, powerful Neanderthals. Still others moved across Asia, becoming the mysterious Denisovans who thrived in high mountains and distant islands. The return of the rains had not only saved humanity, it had set the stage for humanity to divide into different forms, each a response to the world it encountered. The recovery was not fast. Generations still lived and died under harsh skies, and droughts still returned with devastating force. But the difference now was that these disasters were survivable. The planet was shifting toward a new rhythm of ice age cycles, lasting 100,000 years. But within that rhythm were windows of opportunity. In those windows, humans expanded, exchanged ideas, and established the foundations of cultures that would last. Looking back, the slow return of the rains was more than climate recovery. It was the opening of a new chapter. Humanity stepped out of the bottleneck, not as a single desperate band, but as a branching family. From those few survivors came the ancestors of all modern humans, Neanderthals and Denisovans. The world had almost erased us, but as the clouds gathered again, it handed us the chance to grow, adapt, and spread across continents. The near extinction was ending. The human story was ready to widen. Tens of thousands of years after the bottleneck eased, humans who had once been one tiny population began to encounter their long-lost cousins. The world was no longer empty. Across Europe and Asia, Neanderthals and Denisovans had carved out their own strongholds. They were not so different from us, yet different enough to be recognized as other kinds of humans. When our ancestors stepped out of Africa and crossed into new lands, they did not find untouched wilderness. They found family at the crossroads. The first meetings must have been tense. Imagine a small group of modern humans, lean and resourceful, moving into a valley already occupied by Neanderthals. The two groups watch each other from a distance. They share fire, tools, and a similar intelligence, but their bodies carry clues of separate histories. Neanderthals were shorter and stronger, with wide noses and heavy brows built for cold. Denisovans were even more mysterious, living in far eastern mountains and forests. What happened when these groups came face to face is written not in stories but in our DNA. The evidence is undeniable. Modern humans interbred with both Neanderthals and Denisovans, not just once but many times over thousands of years. Today, people of non-African descent carry about 2% Neanderthal DNA. Populations in Asia and Oceania carry traces of Denisovan genes, sometimes as much as 6%. These genetic fragments are living proof that our ancestors did not just compete with their cousins. They shared lives, built families, and had children together. But cooperation and intimacy were not the whole story. Competition was real and often brutal. Neanderthals had thrived in Europe for hundreds of thousands of years before modern humans arrived. Denisovans had adapted to extreme environments that our ancestors were only beginning to explore. When modern humans pushed into these territories, they brought with them new technologies, more flexible survival strategies, and larger social networks. Slowly, the balance of power began to shift. Archaeological evidence shows this clash clearly. For long periods, Neanderthals and modern humans shared regions of the Middle East, sometimes replacing each other as climates shifted. The boundaries between groups were fluid, but over time, modern humans expanded while Neanderthals retreated. In Asia, Denisovans seem to have survived longer in isolated regions, but even they eventually faded as modern humans spread across the continent. What is astonishing is that even as these cousins disappeared as distinct species, their DNA lived on in us. Some of the genes we inherited gave us advantages. From Denisovans, Tibetans gained a genetic variant that helps them survive at high altitudes. From Neanderthals, modern humans gained immune system tweaks that helped them resist new diseases. These gifts from our cousins became part of our survival toolkit. Cousins at the Crossroads is not just a story of extinction, it is a story of exchange. When humans met Neanderthals and Denisovans, they did not erase them completely. They absorbed pieces of them, carrying fragments of their lives into the future. Every person alive today is proof of those ancient meetings, a living archive of encounters that happened tens of thousands of years ago. When modern humans finally spread across the world, they did so at the expense of their cousins. Neanderthals had ruled Europe for hundreds of thousands of years. Denisovans thrived in Asia, adapting to mountains and islands. Yet within a few tens of thousands of years after our ancestors left Africa, only one branch of humanity remained. We won, but the victory came with costs written in our DNA. The main reason we survived while others faded was flexibility. Neanderthals were masters of hunting large game in icy landscapes. They built strong bodies and tools for a narrow but highly effective way of life. Denisovans adapted to their own extremes, like high-altitude plateaus and island crossings. But when environments shifted, their specializations became traps. Modern humans were different. We had learned during the bottleneck to eat almost anything. Roots, insects, shellfish, birds, small animals, our diet was broad, and that meant we could survive in places where our cousins could not. Innovation also gave us an edge. Neanderthals made excellent tools, but their methods changed slowly. A hand axe style could last hundreds of thousands of years with little adjustment. Modern humans, on the other hand, were restless inventors. By 45,000 years ago, we had blade technology, tailored clothing, fishing gear, and art. Our ability to quickly test and share new ideas meant that we could adapt to changing climates far faster than others. When the ice shifted or prey disappeared, we created new solutions rather than waiting for the old ones to work again. Social networks played another crucial role. Modern humans built wider alliances, often trading across long distances and linking groups through marriage. This web of connections meant that if one band suffered disaster, others could help them recover. Neanderthals and Denisovans lived in smaller, more isolated groups, making them vulnerable to sudden shocks. Our invisible roads of exchange became safety nets that kept our populations strong even in hard times. But survival came with hidden costs. During the bottleneck, humanity lost about 65% of its genetic diversity. That meant when we expanded, we carried fewer variations in our DNA than our cousins did. Neanderthals, even though fewer in number, actually had more genetic variety in some areas of their genome. Our lack of diversity left us with weaker immune systems and made us more vulnerable to diseases. Many of the genetic disorders common today are a direct result of that ancient narrowing. We may have been better at surviving environments, but we were more fragile inside our own cells. Why we won is not just a story of superiority, it is a story of trade-offs. Our flexibility, creativity, and cooperation let us thrive in a world of shifting climates and scarce resources. But the scars of near extinction stayed with us, shaping our vulnerabilities even as they powered our success. We became the last humans standing, not because we were the strongest, but because we were the most adaptable. And adaptability, for better and worse, became the hallmark of our species. When you look at the way humans live today, it is easy to think our traits are the result of modern times. Our teamwork in sports or business, our obsession with learning and teaching, our constant drive to build new tools and technologies. But these are not recent habits. They are echoes of the past, forged in the crucible of near extinction 900,000 years ago. The present is written in the past, and our daily lives still carry the fingerprints of that ancient struggle. Take teamwork. Humans are uniquely good at working together in large groups. We cooperate with strangers, build massive cities, and even send teams into space. Chimpanzees, our closest relatives, can only manage cooperation in small circles of about 50 individuals. That difference was not random. During the bottleneck, small scattered groups had to depend on each other so completely that cooperation became a survival instinct. If one person failed to share water or food, the entire group could collapse. Over more than 100,000 years, natural selection favored those who could cooperate best. Today, our instinct to work together in everything from classrooms to workplaces is the inheritance of that pressure. The same is true of our teaching instinct. Unlike most animals, we do not simply let our children learn by trial and error. We actively show them how to do things, from tying shoelaces to solving equations. This impulse began when knowledge was more valuable than any material resource. An elder who knew where to find food in a dry season or how to make fire had to pass that skill on. If they failed, their group might not survive the next drought. Teaching became so important that our brains evolved to reward it, making the transfer of knowledge one of humanity's strongest instincts. Our obsession with tools is another ancient legacy. From smartphones to skyscrapers, humans see the world as raw material waiting to be shaped. That mindset began with stone axes and fire, technologies that meant the difference between life and death in the bottleneck. People who could invent better tools, and people who could learn to use them quickly, survived at higher rates. Over thousands of generations, humans became a species that views problem solving through the lens of technology. That is why every generation, even today, produces new tools that redefine what survival means. But the past also left us with vulnerabilities. Losing so much genetic diversity during the bottleneck weakened our immune systems. It is why humans are unusually susceptible to infectious diseases, and why genetic disorders are more common in us than in many other animals. These weaknesses are scars carried forward, constant reminders that our survival was once hanging by a thread. The present in the past is more than just a story about where we came from. It explains why we are the way we are. Every time you teach a child, work with a team, or invent something new, you are continuing traditions that began in the darkest chapter of our history. Our strengths and our weaknesses both trace back to that ancient test, and they are still shaping the future of our species today. One of the most powerful lessons hidden in the story of the bottleneck is that all humans are family, not in a poetic sense, but in a literal genetic one. When our species shrank to just over 1,000 breeding individuals 900,000 years ago, every person alive today became a descendant of that same tiny group. After the bottleneck, humanity carried forward as one close-knit family, and that truth is written in our DNA. It is easy to look at the differences between people today and imagine they are vast. Skin tones, hair textures, facial shapes, and languages create the illusion of deep biological divides. But those differences are recent, small, and local. They emerged only in the last 50 or so thousand years as groups adapted to the climates and environments they moved into. Darker skin helped protect against the intense sun in equatorial regions. Lighter skin made it easier to absorb vitamin D in northern latitudes. Eye shapes, body builds, and other features followed similar patterns shaped by geography, not by separate origins. Genetically, humans are shockingly alike. Two chimpanzees living in different forests in Africa are often more different from each other than any two humans on opposite sides of the world. That low diversity is the direct result of the bottleneck, when so much variation was lost. It means that under the surface we are far more alike than most people realize. There are no separate biological races within humanity. There is only one family, one lineage, one survival story carried through time. The bottleneck also explains why we can all intermarry and have children together, something that would not be possible if there were deep genetic divides. Instead of splintering into separate species, our ancestors stayed connected. Even when humans later spread across continents, they carried the same core genetic signature. The differences that developed are like regional accents, small adaptations layered on top of a shared voice. Understanding this truth matters. It shows that ideas of superiority or separation based on race are myths, not science. The real story is that we all come from the same fragile beginning, the same desperate struggle to survive a world that nearly erased us. Every person alive today carries genes from those 1,280 survivors. That is a bond stronger than any difference in skin or culture. The lesson of one family is both humbling and unifying. It means that when we look at each other, we are looking at close kin, no matter how far apart our ancestors travelled. The divides we imagine are recent illusions, born of environment and history, not biology. The reality is simpler and more profound. We are one family, forged in fire and drought, tested by 117,000 years of near extinction, and carried forward by the shared resilience of a single human lineage. 900,000 years ago, humanity was nearly erased. Only about 1,280 survivors carried us through a climate disaster that lasted over 100,000 years. They did not endure because they were the strongest or the biggest. They endured because they were stubborn, adaptable, and willing to change everything in order to stay alive. That legacy is still in us today. We are the descendants of people who refused to surrender when surrender seemed inevitable, but their story carries both a promise and a warning. The promise is clear. Humans are capable of surviving almost anything. When the world turned against us, we learned to cooperate, to teach, to build tools, and to speak. We invented culture as a survival strategy. Every skyscraper, every rocket, every hospital, every classroom is an extension of the instincts that carried us through the bottleneck. Our adaptability is unmatched in the animal kingdom. We can live in deserts, frozen tundra, mountaintops, and even orbit above the planet. That capacity was forged when our numbers were so low that failure meant extinction. It proves that when tested, humans can rise to impossible challenges. But the warning is just as important. Survival is not guaranteed. The bottleneck shows that our species is not invincible. Climate change once reduced us to the brink of disappearance, and climate change threatens us again today. Back then, we had no choice but to adapt or die. Now, we have technology, knowledge, and foresight, but also new dangers of our own making. Our global population is vast, but our genetic vulnerabilities remain. Diseases, environmental collapse, and conflicts could still undo what our ancestors fought to preserve. The bottleneck also reminds us of how fragile civilization can be. For more than 100,000 years, our ancestors lived in tiny groups, constantly on the edge of starvation, one accident or drought away from disaster. It took only one refuge, one hidden valley, one network of families to carry the flame forward. That means survival depends on choices. 1,000 small decisions saved us then, and 1,000 small decisions will save us now. Whether it is how we treat each other, how we care for the planet, or how we prepare for challenges, the lesson is that humanity endures by working together. The promise and the warning are bound together. We know from our past that we can adapt, cooperate, and create solutions faster than any other species. We also know from our past that ignoring threats or clinging to rigid ways of life can nearly destroy us. Our ancestors were survivors, but they were also vulnerable. We are the same. The difference is that now we have the power to choose our future with clearer eyes. Every person alive carries the genes of those who would not give up. That means the stubbornness to survive is already inside us. The bottleneck did not just shape our past. It is a message for our present and future. Survival is never guaranteed, but neither is surrender. As long as we choose to adapt, to cooperate, and to hope, the story of humanity will keep going.